Welcome to the best practices panel of the GREEN4SEA virtual forum. In this panel, we would like to discuss on a number of issues that we are facing on a day-to-day basis across the industry. In order to help protect the environment, many organizations are taking measures to lessen the environmental damage of their operation while enhancing their performance. Nowadays, it's the climate change being one of the biggest threats of the industry. It is imperative for all of us to behave in an environmentally responsible manner. Now, we cannot sort out any sort of issues that we may face in the industry on a daily basis, but we would like to discuss with 4 presentations and 4 panelists what are the industry's best practices to enhance environmental awareness and performance, what are the key challenges on a practical issues, how, let's say, a practical and hands-on approach may assist, especially the ship managers to do their work and carry out their objectives, let's say, more effectively, to put in that sense, and any best practices and lessons to be learned from the past or from other industries, and so on and so forth. Now, to have this discussion, we have gathered a panel of experts. Let me introduce them to you. We have Martin Ness. Martin is the International Sales Manager of Aqua Metro Oil and Marine, GmbH. We have Jean-Philippe Gagnon, who is the Field Engineers Application Specialist for Telops. We have Sarah Zitouni, who is the Regional Sales Manager for Lean Marine. And last but not least, we have Tom Evanson, who is the Regional Category Manager for Hull Performance for Jotun. Now, as we have this first order of business out of the agenda, I would like you to start your presentations, starting right away with Tom. Tom, you can share your screen and let us have your presentation.
So, ladies and gentlemen, many thanks for giving me the honor to present to this esteemed audience. My name is Tom Evanson, and I work for the coatings manufacturer Jotun, who by now do far more than merely produce and sell paints. Hence the title of my presentation, call it artificial intelligence, we call it fuel savings. In this brief presentation, we wish to provide a best practice approach towards tackling the biofouling challenges from a hull performance point of view. Now, the shipping industry is facing increased challenges related to biofouling. The 4th IMO greenhouse gas study disclosed that biofouling alone accounts for the emissions of around 83 million tons of CO2 and 2 million tons of other greenhouse gases per year. At a modest average fuel price set at $400 per ton, the industry cost would excess fuel consumption is around $11 billion again per year. And in addition to this comes hidden costs such as delays, legal fees, hull cleanings, and so on. Further to this, biofouling also contributes to the transmigration of non-indigenous species, affecting biodiversity and triggering staggering cleanup costs. There are forthcoming international regulations that indirectly will affect how the industry handles the biofouling challenge. Out of the recently held MEPC 75 came EEXI, so the Energy Efficiency Index for existing ships, the Operational Carbon Intensity Indicator, which both will include a rating scheme as well as an enhanced ship energy efficiency management plan, and they're all expected to enter into force January 1st, 2023, so in less than 2 years from now on. So how is the industry working to address the biofouling challenges? What we typically see is that reactive hull cleanings are being conducted, and they have some serious implications. Hull maintenance is often triggered via monitoring systems or periodic-based reactive cleanings. And one of the main implications of reactive cleanings is simply that time to decision, and not the least time to action, is too long. The reactive cleanings are often complex operations and quite costly. And there is an underlying risk of potentially damaging the anti-fouling system, as well as risk the spread of aquatic invasive species. There are health and safety concerns, as well as the need to collect any debris to avoid possibility of increasing pollutants and also to keep the biosecurity risk under control. Jotun has from early on been a firm believer in measurability, and we are also one of the initiators behind the ISO 19030 standard in measuring hull and propeller performance over time. And what you see here is a performance plot over 5 years for a typical bulk carrier in a worldwide trade. And in this case, the average performance loss of this vessel is at 5.9%, which is where the estimated market average speed loss is expected to be at. If this vessel was to overcome the additional frictional resistance from accumulation of fouling, they would have to spend a whopping 18% additional fuel to overcome the frictional resistance. In the analysis, we also disclosed that there had occurred 4 reactive cleanings. And this also has to be taken into account, the complexity associated with this. Jotun have introduced proactive cleanings with something that we call hull skating. This is fundamentally different from conventional cleanings, as a normal cleaning is reactive, while hull skating is proactive. An advanced fouling prediction algorithm dictates just the right time to proactively clean the hull. It leaves an unbeatable environmental footprint because there is limited and minimal performance loss, and there's no debris contributing to transmission of invasive species. It offers full operational flexibility, in addition to hull state verification capabilities 24/7. The solution consists of a range of components, a specially designed self-polishing anti-fouling, a very sophisticated fouling prediction algorithm, a set of Jotun-employed skate operators that are located in various operational centers across the globe, and the delivery is backed by solid performance guarantees. Jotun might have good ideas and be good in producing coatings and paints, but we had to team up with some strong industry partners in bringing this solution to the market. Kongsberg Maritime being one of these, in addition to Semcon Devotech, DNV GL on the regulatory side, and Telenor on the communication side, and shipping partners, Wallenius Wilhelmsen, Maersk Line out of Copenhagen, and Berge Bulk out of Singapore. Now, this fouling prediction algorithm is one of the key deliverables in this solution. And it's an in-house developed fouling prediction algorithm where we use data fusion approaches with multiple data sources, starting off with high resolution AIS, and then we add relevant idling data such as location, length, distance to shore, bathymetry, and then couple this with the oceanographic dimension, which is collected live from sources such as NASA, Copernicus, European Space Agency, and so on. And then we take parameters such as chlorophyll concentration, oxygen, sea surface temperature, and many, many more to predict when the optimum time to proactively inspect and proactively clean the hull. The solution is typically being installed during a dry docking where this special paint is being applied and the robotics being installed. And early indications lead us to conclude that we would be delivering on a maximum average speed loss of no more than 0.5%, which would be a market-leading hull performance. Over this dry docking interval, the vessel would require no more than 1.5% increase in power in order to compensate for the minor speed loss that has occurred. I mentioned earlier that measurability is key. And if an additional investment can't be measured, the return on this investment, the investment itself has no or little value. Now, we have run a business case on, again, a typical bulk carrier, modest use of heavy fuel oil at $400 per ton. And in this case, we see a net return of investment in the range of $2 million, in addition to a CO2 savings in the range of 25,000 tons. And that, ladies and gentlemen, concludes my presentation. And I would like to take the opportunity to thank you for tuning in, and also feel free to contact me if you have any additional questions. Thank you very much and take care.
Thank you very much, Tom. Let's hear from Sarah. Sarah, you can share your screen and let us have your presentation.
All right, thank you very much for tuning in. I'm very happy to be presenting today at GREEN4SEA. My name is Sarah Zitouni and my background is as a mechanical engineer and actually within engine design. But today I'm happy to speak about Lean Marine and what we have done to help our customers and the best practice we can recommend you to tackle the environmental challenge that we're all facing. So basically, the pressure is only rising to act on the climate emergency by regulators, but also by the audience and the public, which is very concerned to see the black smoke coming out of our funnels. So the question really is, what have you done so far to reduce the carbon footprint of your fleet? And let me suggest some measures that maybe you have not thought about yet. But first, just a quick word about where those measures have been applied. So actually, Lean Marine have been existing for almost a decade now. And within that time, we have served more than 50 customers. We've now equipped right now 200 vessels, and we're very happy and proud to mention that figure. And more important than all, thanks to our technology, 186 million kilograms of CO2 every year are spared to the environment. So let me show you how. Most importantly, let's speak quickly about regulation. So the IMO is actually putting pressure on every single one company, every single one of us to actually guide the industry towards more reduction of greenhouse gases. And as you may know, we currently have two new indexes coming up. So the energy efficiency existing ship index, but also the carbon intensity indicator. Those will come with ratings, and you might be concerned and wondering how you could actually tackle this new challenge. So how to attain these new IMO targets? Well, there's actually a couple of ways to do it in both cases. Regarding the EEXI, let me focus on the engine power limitation and the shaft power limitation side of the force. But there's also other ways to do it, like energy efficiency technologies or alternative energy sources. Regarding the CII, that seems to be also particularly interesting to a lot of charterers, as we have heard it ourselves firsthand. Data collection, performance management, and continuous improvement loops are going to be paramount. And maybe we could help you with that. So in the case of shaft power limitation, let me mention fuel up, and I'll get in a second in more details about it. It's an automated direct fuel saving method that, as I said, was already proven on board more than 200 vessels. And regarding the data management and performance management on your vessel, let me mention fleet analytics. That is the best way to turn vessel data into knowledge and make sure that whichever data you have on board will be treated in the best manner to actually provide you with correct, useful inputs so that you don't just drone in the middle of big data. So what about fuel up? Fuel up is our patented solution. As I said, it's an automated direct fuel saving method. It's actually automation on board your vessel made simple. Basically, we close the missing link that you have today, where you can't control the speed or the fuel consumption or the engine power directly. With the current lever as you have, what you can control is RPM or a combination of RPM and pitch. We give you a tool on board that allows you to set the required value within speed and consumption and then activate in order to work just like any cruise control you could think of that you have maybe on your car, for instance. So what does that provide you? Well, first thing is that you get real-time propulsion optimization, and then that results in reducing power variations. Power variations are costly. They are actually operational mistakes that cost you a lot of fuel on board a vessel and during a journey. You also get, as I mentioned, direct control of speed, consumption, power, or a combination thereof. That means that you are more likely to fulfill your charter party agreement and also reduce your fuel consumption and hence the emission of greenhouse gases, which is what keeps us all busy here. Also, you would get actually a prevention tool to prevent you from the overconsumption that occurs in adverse conditions, what I call here simply bad weather. But any adverse current conditions or storm could cost you a lot if they're not mitigated quickly, and Fuel Up will actually help you mitigate that quickly on board a vessel. And for CPP vessels, for those of you who have controllable pitch propellers, then we also do an adaptive and real-time pitch RPM optimization. But let's get back to EEXI quickly. I mentioned it and then I mentioned Fuel Up. So what's the connection? Well, the connection is that Fuel Up is a smart way for you to derate your engine power output. As I said, I'm a mechanical engineer and I do get nervous when I see people derating engines with less than conventional manners. So I hope that here I can provide you a way to actually control your power and derate your engines that will not be too harsh. So actually, this is likely to be the primary and most efficient measure to reduce the greenhouse gases emissions. And how do we do it with Fuel Up? Well, we enable like an electronic limit on the engine that limits the shaft power output. That means that there's no modification that is invasive on your machinery. That means that that power is still available on board. So would you need it for emergency reasons, God forbid, then you still have access to it. And with Fleet Analytics, you'll actually get the data recording that is required by the regulators to be able to show what were the reasons for you to actually break the power limit in that case. So it will help your reporting in that sense as well. In terms of fuel cost, how do we save fuel with Fuel Up? So basically, volatility has a cost. A lot of you are probably already aware of this fact. That was both if you have a fixed or controllable pitch propeller vessel. And here I want to show you real data from a vessel. As you see on the left, you actually have a vessel without Fuel Up. So main engine RPM is kept steady. This is a bulk carrier. And as you can see, looking at the speed through water, at some point it drops while the consumption goes up. This is typically the behavior that will happen in harsh weather conditions. You can see this behavior does not happen with Fuel Up. When the speed through water drops because you're in adverse conditions, the consumptions remain steady. So you're not losing on both boards, basically. You're okay, the speed might be what it might be in a bad weather, but you're not paying it with the consumption. So the target here is to keep steady and predictable shaft power. And what's the result on this bulk carrier, 200,000 deadweight? Well, actually, for an average consumption of 35 tons per 24 hours on this vessel, it's a small engine. The fuel savings on 1 year were of 225 tons of fuel. Let me quickly mention for controllable pitch propeller, we can also regulate the propeller pitch and the RPM of the engine separately. And as you can see on the graph, the consumption is reduced instantly. The results of that, more than 600 tons of fuel being saved in 1 year. So the return on investment of this solution is below a year, and it has been for every single one of the 200 vessels we have equipped. So please come and talk to us. Our planet can't wait. We need to save fuel and lower CO2 emissions. Thank you very much for listening to me today.
Thank you very much, Sarah. Can we have Jean-Philippe to present? Jean-Philippe, can you share your screen, please?
Yeah, thank you. Thank you very much for giving me the opportunity here to present to you at Safety4Sea today. So my name again is Jean-Philippe Gagnon, and I'm a field application engineer at Telops. So in this presentation, I want to show you how our hyperspectral cameras can quantify the gaseous emissions from ships, mainly sulfur dioxide and carbon dioxide. And from that, infer the sulfur content of the fuel oil used by the ship. So this technique brings distinct and very interesting advantages for verifying compliance to marine environmental conventions. So let's dive right in. Second slide. So as you may know, of course, marine vessel emissions include NOx, SOx, so those are NOx or SOx, carbon dioxide, carbon monoxide, and volatile organic compounds. But for this particular presentation here, we'll turn our attention to sulfur dioxide. SO2 emissions in the exhaust gas is derived completely from the fuel sulfur content, as most of the sulfur in the gas is converted to sulfur dioxide during the combustion process. Here, the International Convention for the Prevention of Pollution from Ships, or MARPOL, defines limits on allowable sulfur content in ship fuel oils. And as of January 2020, the limit for SOx and particulate matter emissions decreased from 3.5% weight ratio to 0.5% weight ratio. So there's really a need for a system capable of verifying compliance to this regulation. In the past, monitoring of marine emissions in plumes have been recorded using various methods. Passive detections at coastal sites, like here, where in some ports, ships are due to pass under bridges, and those bridges can be instrumented with point sensors that detect sulfur dioxide or CO2. Plumes have also been monitored using differential optical absorption spectroscopy with good results, but these are non-imaging techniques, so it's just single pixel. And also, they do require the ship and its plume to pass at a certain exact point to be measured. Measurements of maritime emissions have been reported using more active sampling methods, such as here, images shown here where either aircrafts or drones have been equipped with sensors to fly very close to the plume to measure SO2 and CO2 emissions. As you may know, each of those techniques are limited in some ways. So a year ago or 2 years ago, we started looking at how our hyperspectral cameras can help monitoring these gases. So we set out to see, to use our hyperspectral cameras to see here to measure SO2 emissions. So the performance and efficiency of the HyperCam, which is the name of the camera, as a remote chemical agent detector has been proven through numerous field campaigns since 2006. And as you can see here are several examples. The camera is used in several applications, ranging from detection and identification of various gaseous compounds in the industrial, environmental, and military sectors. So the camera, well, there you go. So a few pictures of how we developed the technique. So we took advantage of the fact that Teleops here is located near the St. Lawrence Seaway here in Canada to deploy the hyperspectral camera and measure several ships. In this configuration, the camera is fixed on the tripod and simply record images as the ship passes in the field of view. For this specific experiment, we use our new, smaller and compact version of the hyperspectral camera. So an evolution that comes from the development of our airborne system that you see here. How do we do it exactly? Well, to analyze the data, we are using a standard radiative transfer modeling technique. This is standard in infrared hyperspectral imaging. So we really take advantage of the fact that we have an imaging system to select different pixels. And based on the information that we get from those pixels, we're able to solve the mathematical equation and really compare the measurement to our modeling technique. If we have an agreement, then we have solved our model and we can determine very accurately the composition of the plume itself. So we can come up with concentrations of SO2 and CO2 gases in the plume, just from a simple image that we took of the ship. And knowing the SO2 and CO2 concentration and performing or assuming three basic assumptions, which are common in the literature, such as the fact that the sulfur content in fuel is converted almost completely to SO2, all of the carbon is converted to CO2, and the last assumption is that the average mass fraction of the carbon is around 87%. So if we make those assumptions and from our measurements, we can deduce the sulfur content of the fuel being burned. A few experimental results just to illustrate the what kind of results we can have. When the gas concentration or the SO2 gas concentration is sufficiently high, the plume can be detected in real time, as shown here in the video of the ship just passing in front of the camera. Here, the plume is clearly visible in pink. So our system detects it in real time and highlights it. Also, during the initial campaign, we imaged 4 ships here in Quebec City. So the results I've indicated here, you can see quite a good agreement with other techniques. In fact, 2 other techniques. We were fortunate enough to have a very good collaboration with either ship owner or Transport Canada here, which is the regulatory body in Canada. So both of them provided us with values to compare our data against. And turns out that we know the reasonably good agreement between those measurements. Well, what are the next steps? So here we have developed a framework that, based on the results we obtained, show that it is possible to retrieve sulfur content of the fuel based on simple hyperspectral imagery of the exhaust plume of the ship. So future work involve increasing our data set, as well as using our new Hypercam Airborne Mini to try and accomplish the same task, but this time from the air. So again, I would like to thank you for giving me the opportunity here to present our technique and to you. So again, thank you for your time.
Thank you very much, Jean-Philippe. And let's hear from Martin to conclude with this round of presentations. Martin, can you start sharing your screen to let us have your presentation, please?
So also thank you from my side, and welcome to my presentation of fuel performance and energy efficiency and how we tackle the actual and upcoming environmental tasks and challenges. First of all, I want to introduce myself. My name is Martin Hees. I'm the International Sales Manager for Aquametro Oil and Marine. And as a short introduction of the company, Aquametro Oil and Marine is now since 50 years one of the leading companies in fuel oil consumption measurement and performance monitoring systems, not only in the marine business, but also on off-road systems and off-road applications like diesel gensets, like burner, boilers, and all kind of trucks and vehicles, besides the oil meters. We are experts for viscosity measurement, shaft power, steam control, monitoring and management systems, which you have seen now already, some examples, and changeover and blending units for fuel. So what are the challenges we are actually facing right now? And the challenges are the environmental awareness, which was raised in the marine industry. And as a consequence of this, several regulations have been set up between 2005 and 2020, dealing with reduction of SOx and NOx. And in recent times, the energy efficiency design of the vessel was a target. And in future, we are dealing mainly with the reduction of CO2 until 2030, 2050. So with all these actual regulations, as well with the upcoming ones in the next 20, 30 years, the need for increased measurement of the vital parameters is a must. And I talk about the vital parameters and not about the big data, which you hear very often from other speakers. Vital parameters, because we at Aquametro believe that not only big data is the priority, but the basic values within the engine rooms, with the engine compartment. We believe that measurement of these parameters is the foundation of improvement of vessel efficiency, and therefore, as a consequence, the reduction of SOx, NOx, and CO2. We say measurement of the basic data is a must nowadays for every vessel, and because everything else is guessing. And this cannot be the goal of a modern vessel operator. So we say measurement is the key and the foundation of a good monitoring system. And you can only monitor, only what you can measure. When you want to improve your performance and efficiency, start by measuring the basic data. That's what we always mentioned. And one of the easiest and most obvious places to start is by measuring the fuel consumption and the propulsion efficiency. Fuel efficiency is the key of saving the money, since fuel costs are between 50 and 70% of vessel operating costs. Fuel efficiency is the key for saving money. Fuel performance monitoring and fuel performance monitoring systems also helps in achieving the environmental goals of the shipping company. And of course, real-time data, we heard this before, is the foundation for decision making, for savings and energy reduction. By implementing the fuel monitoring systems, the operator will get live and real-time indications of the vessel's immediately full efficiency. So what is a set of basic data I always talk about, which we can offer as retrofit for newly builds, but also for existing vessels. So first of all, and most important, what we say are the fuel flow meter for all kind of main auxiliary engines and boilers and all kind of fuel flow measurement points within the vessel and within the engine rooms. With the new fuels coming up, viscosity control and steam control is also a priority in the equipment of the engine compartment, the engine room. And fuel switching and blending systems, even under scrubber operation, is a main task we are now looking for. We offer fuel homogenizers and shaft power and torque systems, and combining them all together, we as well sell data collection, monitoring, and performance tool to all bring this data together. So if you talk about the main and the basic parameters, we have to talk about the fuel meters, and what you see here are the well-known Cont Oil VZF2 type family mechanical fuel meters, which have been tested and used in the marine industry for many, many years. They are taken through rough testing like burst pressure and vibration tests and flame endurance tests to prove its safety and accuracy in measured fuel, even in the most difficult working environments. And they offer highest accuracy. Most of the people think that these mechanical systems, they come down to 1 to 2% accuracy, but no, these systems are calibrated even to accuracy of 0.3 down to 0.1% accuracy, and they give volume and mass flow output as well. They offer a compact design, space-saving installation in all positions without any straight inlet or outlet requirement. That means you can install them in a valve or angle situations. Due to their compact design, they offer space-saving installations, as I said, and you can mount them in any positions within the engine rooms. And they are nowadays a real competitor to the so-called Coriolis meters if it comes to accuracy and mass flow output. If we talk about measurement itself, we have to talk about viscosity measurement, viscosity control with the innovative vibrating fork system. They can replace easily the old DP units and are a valuable systems for all the new fuels which are coming up with all the different parameters. A reliable shaft power, we have this as well in the past, and torque system operated can contact free and can easily be retrofit in the propulsion systems for total cost of under 15,000 euros, including the commissioning. And nowadays, with the COVID situation, we also offer commissioning online with different kind of tools. So the next one is the management and treatment sections. And here we talk about treatment of different kind of fuels. And we show the diesel switch system, which is a unit for automated changeover as well as blending for different fuels, especially under scrubber operation. These systems fully comply with the MARPOL regulations, and you get rid of all manual changing and blending operations. A homogenizer here, what you see down, installed in the fuel system as well in the fuel tank circulation, is a must-have device for all new fuels, as it increases the compatibility of the fuels and decreases the content of sludge on board. Furthermore, a reduction of asphaltene and cat fines can be reached with this easy to retrofit homogenizing unit. And as I said, we bring all together this data in a fuel performance systems like the FPS to get the all KPI analysis and trend curves. So as I said, to summarize it all together, we offer systems for diesel switch and diesel changing, homogenizations, viscosity control, fuel meters, and shaft power systems, which give you a big package round in the engine rooms to measure all reliable data. With that saying, I want to thank again the organizer for Safety4Sea for bringing up this such great event under these circumstances, and feel free if you have more need for information to contact one of our head office in Switzerland or Germany. Thank you very much.
Thank you very much, Martin. Tom, you shared with us a number of practical findings. May I ask, how many years in the market is the solution that you have?
The solution that I mentioned, hull skating solution, was brought to the market on the infamous date 12th of March 2020. So in 1 week, it's going to be 1 year ago. And the reason I'm saying the infamous date, because it's the same date that Norway closed down. So we were kind of robbed of our global launch, but we are making great progress, even though we have strange times.
More or less what happened in other places across the globe.
Yes.
During that week, and that was a Thursday. On up to Friday, I think most of the European economies shut down. Yes. with a lockdown, and not only in Europe but in other places of the world as well. So may I ask, you presented some insights because you have some data that you analyze, etc. Are you planning to share some of these insights with the market or something? Do you have any plans on that?
Absolutely, and we have done over the years. This is also the reason why kind of like Jotun methodology ended up being ISO 19030. We believe in transparency, we believe in measurability. And in order for best practice adaptation, you have to measure, validate, and also then share, so that others can benefit from the good findings we have among leading ship operators.
Okay, and from what I understand, what you presented was extremely practical, let's say, to put in that sense. Yes, yes. Have you seen any sort of resistance in the market towards the methodology that you propose?
I mean, the methodology, it's not a perfect methodology. I mean, there's so many factors influencing. We have SADA, which from an educational point of view can validate this, but you have weather and wind, you have engine, train, and propeller condition, and so forth. But at least you're measuring, at least you're collecting data, and this is the starting point. Methodology will get better. We have created now a feedback loop where we use visual confirmation on the hull. We have the oceanographic, the fouling pressure dimension, and then obviously we have the performance dimension as measured. And this feedback loop will over time calibrate the measurements and then make it more and more accurate.
Yeah. Let's move to Sarah. Sarah, you mentioned 50 clients, 200 ships. Your solution, I assume from what you presented, is something applied locally. There was no interconnection between ship and shore, correct? You don't need satellite.
Oh, actually both. So the solution itself, which gives you the possibility to control speed, engine power, or consumption directly is installed on board. It's non-invasive and it's to be handled on board. But I fully agree with Tom that knowledge is power, and that people will be empowered from knowing what is going on board. So Tom mentions the hull, I can mention the machinery, the engine, the turbocharger, what's going on. And because of that, our solution actually pushes out data to the cloud, and through fleet analytics that I mentioned briefly in my presentation, allow you to look at the data, to return also your MRV reports and all the other reporting that needs to be done much simpler, automatized. But most importantly, look at the data, realize what's going on, have early warnings for different aspects on the machinery, rather than, late findings.
And how many years you're working with this solution?
It's been 8 years now, so this is the results we have after 8 years, and we're looking forward to really expand this further.
So we've seen in the market up to the early 2013 with the introduction of SEMP, and there was also a crisis back at that time because of the fuel prices, and we've seen the market, pivoting towards seeking more, let's say, better fuel performance solutions in that sense. And we've seen that the ship operators have started measuring and remeasuring and adjusting and optimizing, and we've seen that progress. So I would like to ask, are you planning to share, out of these insights you have, what sort of early wins may be applied into what sort of machinery? Do you have any sort of insights to give us some, let's say, tips of where someone might, let's say, focus on to get some early wins or easy wins, to put in that sense?
Okay, I see. So actually, you'd be maybe surprised, but out of these 200 vessels, we have equipped almost everything there is out there. So research vessels, bulk carriers, passenger vessels, cruise vessels, really literally everything there is out there. Of course, for the easiest wins, the quickest pickup, the return on investments that are a matter of months or voyages, not even a whole year. These are to be found with vessels who have a controllable pitch propeller, because we can optimize pitch and RPM, and this gets spectacular results, like we're talking double-digit savings, or vessels who have very long journeys, ocean going. So large bulk carriers or large container carrier vessels are our favorites. They tend to have very long journeys. Every small error, every small mistake where you don't adjust the speed fast enough in adverse conditions will cost you so much in the Pacific Ocean or the Atlantic Ocean, and Fuel Up prevents that. So again, you can get double-digit savings in these cases.
Okay, thank you, Sarah. Jean-Philippe, you presented a solution that is more or less useful for a number of reasons. What sort of clients do you have so far for the solution?
Yeah, that's a good question. So right now our technique is pretty young. So, but even though we're developing at the moment 2 units, and those units will be installed later this year in a port in Asia. So one port will be equipped with these 2 prototype units to gather. The idea here is to gather information, gather more vessels, collect more data, and then use that to feed the model and increase the accuracy and the performance.
And what are your plans with respect to expanding the number of models that you will be using? What sort of time frame do you have?
So these 2 prototypes will be delivered, I think, later this year. So within a year, we'll begin to collect more data. After that, we'll let those units perform there for at least a year in a port, so we can gather data in various type of environmental conditions. And during that time frame, also we are developing, or we want to push forward the new technique, which involves using our camera from the air to go and sample ships, vessels that are further out at sea. So yeah, so during this year and the next year, we'll be putting more and more efforts into that airborne use.
Okay, I assume that you do believe that the technology that you use is a proven technology, meaning it's a reliable technology. And I would like to ask you, I mean, I'm not sure if you can provide an accurate figure on that, but we've seen that the IMO 2020 transition was more or less seamless. But there is a huge but, I mean, over there. But the number of phonars that were registered with the IMO, it was in the range of 30. Now, what we've seen, we know that we're talking about 200,000 bunkerings approximately in the market across, full calendar year, meaning something was gone underreported over there, underreported. So, do you think there's something to be, let's say, gained out of these investigations if you employ drones? You're going to find something that is worth, because we haven't seen any sort of detentions with respect to non-compliant fuels also within this year. What do you expect to find? Because yes, the technology is there. We know that there are certain organizations willing to test the technology and put it into the market. But what exactly do you think it will be, the output of such a program, let's say, to put in that sense?
Yeah, you're right. Various studies that were done in northern France actually, showed that more and more ships comply with the regulations. But that's, I think, that's the advantage of installing our cameras inside airplanes, so we can go further out at sea and measure those vessels that which with current technologies is very difficult to do. So with this system, I think we're going to be able to go out and attack this this problem further out at sea. That's one thing. The other thing is that this technique is not restricted to sulfur dioxide and carbon dioxide emissions. We can also focus on nitrous oxide, so NOx. So we're also putting some amount of efforts into moving toward that direction, toward quantifying nitrous oxide emissions, which is another problematic area.
It is, and unfortunately, this was something we discussed in the previous panel. This is something also going, underreported, because it's expensive to operate at a NOx Tier 3 mode. It's only a mandatory requirement now for ships built after 2016 in the North American ECA, and we haven't heard of any non-compliances. No one has heard of any non-compliances, but we have to be certain that non-compliance exists out there. I mean, it's part of the business. It's part of the business. We don't know to what extent, but as you said, it's going, it's going underreported. I cannot agree more on these NOx emissions. Martin, I would like to ask you about the solution that you presented. You presented, the majority of the presentation was about presenting the practical solutions, and you just gave us a slide about the fuel performance monitoring system that you have in order to put all these bits and pieces into one platform and monitor.
Exactly. Yeah.
Do you have any sort of KPIs / insights or anything, let's say, very useful, like a tip to share with us what we have learned so far, because you're using these systems for a number of years?
These systems are now, I think, 5 to 8 years in our portfolio, and we are coming, as I showed you, from the basic parameters, from the basic measurement, from the flow meters as well, from the viscosity for many years. And these parameters we use together with the newer types of systems like the shaft power and the diesel switch system homogenizations to bring all this data together in a performance monitoring tool and to create KPIs, to create curves, trend curves, propeller curves, for example, for the propulsion systems against different kind of loads. These systems are really a great innovative tools or great innovative systems to have an overview, to have an inside overview about how your ship is running, how your engine is running. We have seen different systems, different solutions from the other speakers if it comes to hull performance, if it comes to control systems, monitoring systems, and we think that measuring the basic data and combining in the performance tool, which is a valuable tool for the ship operator, might be the best solutions, and which can be expanded. I have shown this as well. It's a modular systems, can be expanded and can also take all other parameters, which my speakers before me have shown, can also be connected to these kind of systems. And of course, as you said, KPIs, trend curves is the main focus of interest for the ship owners as well.
May I ask, you are all trying to, hit the same nail, trying to solve, let's say, the same problem, with the exception of Jean-Philippe, who's trying something different, let's say, from the monitoring side. But you are trying more or less to solve an equation, trying to optimize what is going on board ship. I would like to ask you, I understand that each one is, let's say, have a different point of view, not necessarily not providing the same. We have done a lot of progress over the past, let's say, 8-10 years, where we are today. Where do you see the technology as we move forward? Jean-Philippe identified, said, yes, we have a model, we will test this model and we will multiply the model. And he outlined that they will use the cameras with the planes and everything. So we can understand where it will go, let's say, in the next 5-10 years. I would like to ask you, where do you see your technology going within the next 5-10 years with what the market needs? Tom, your thoughts?
It's going to move fast. I mean, shipping is going to be fully digitalized, and regulations is going to force us to do so. I believe, Sarah, you touched on this, data collection, performance management is going to be essential moving forward. And this is really the key knowledge. This is the eye opener. And then you can start getting the most value for the buck, whether it's in terms of CO2 and greenhouse gas emission savings or vessel optimization from a performance point of view. But measurability is key here moving forward.
Okay, Sarah, your thoughts?
I believe that performing just out of previous experience and previous knowledge will not become enough anymore, and that more and more owners will invest in different technologies and solutions to actually aid the decision and also take control on board. I believe there'll be less operational error, more operational excellence. There'll be less human errors on board. For ourselves, Lean Marine, we are going towards machine learning and artificial intelligence to boost our fuel up solution even further, to provide with our customers like even further savings by giving them also the tool to have the best route, the best speed, the best combination of speed and consumption at every step of the way, given with the weather that there is and their of course, contract and so forth. I think also that what will make the progress, other than the regulation that Tom has mentioned, is if we all work more and more hand in hand. So charterers with ship owners, different solution providers, where we'll be happy to work with other alternative fuel sources like wind or other technology, and maybe even with Jotun and their solution. So if everyone works together, we'll be moving forward much faster, definitely.
Yeah, I understand that. Martin, your takes on this?
Well, I fully agree with the topic Sarah mentioned as well before. Our goal also in the future is to create more basic values and basic measuring points within the vessel to get rid of manual operations, to get rid of changeover units manually designed. So go more to automated systems, higher accuracy. Of course, we are working on flow meters. We are working on diesel or technologies for the new fuels as well, besides the HFO and diesel. But we still believe that the HFO and the fuels will stay for another 20, 30 years. And this is the main topic right now with taking actions if it comes to sensors and if it comes to units and systems within the vessel and within the engine compartment.
And I also have to add to what you said, maybe more than 30 years. We are not certain that fuels will be out of the market. What we use as fuels in the next 30 years.
We are not certain as well, definitely. Yes.
We are not certain, because out of this discussion and this uncertainty, nothing happens. And we discuss, and tomorrow we have the day dedicated to other fuel options, other than the conventional fuels, to put in that sense. But it seems that we discuss a lot without anything of significance happening to the market in the near future. I mean, because even for LNG, we are talking about LNG for the past 10 years, and we have not passed the 1,000 ship mark so far.
Right.
Jean-Philippe, your thoughts, where do you see your technology or the technology maybe going forward maybe applied to what you have in the next 5-10 years?
Yeah, it's a good question. This kind of technology, hyperspectral infrared imaging, is quite new, especially for the marine applications. We've been also pushing that technology in oil and gas sector for quite a bit of years now, and I think what our aim is to share the knowledge. Basically, is not everyone knows about the capabilities of this kind of technology, so we're really trying to push this technology and make sure people understand what the capabilities of the technology, what it can do for them. And so the marine sector, marine application is quite new. So we're as I said, we're pushing in various roads, if you want. So this sulfur dioxide business is one of them. So of course, taking this to the air and showing the organizations what this technology can do will help push also this NOx measurement sector also will be important. And one last thing is I think it's crucial to have good collaboration with either the regulatory bodies out there, organizations that we work with, and ship owners as well. We've been fortunate enough to have very good collaboration here in Canada, and we're really hoping to continue doing that as we progress for this upcoming years.
Okay. Now, as we have to wrap up the panel, I would like to ask you to take your crystal ball now, and I would like to ask you to give me your wish list in order to accelerate, let's say, the adoption of the technologies that you provide to the market. So what it would be your wish list in order to eliminate any sort of barriers you see across the industry? Starting with Tom, what's your wish list for the near future?
If I shall try to be brief, as you have asked, I would say that the industry has to move from a reactive response to matters, not just biofouling. So rather than reactive, a proactive. And within proactive approaches lies measurability and insights. This would be my wish moving forward.
Yeah. Sarah?
I think we should put the human at the center of everything. Before looking in the future, I want to look quickly back on the last year and thank again all the sailors that are working so hard out there to make sure for us that it is safe to stay home while still getting every single product, every food product we need everywhere in the world. And I think it's important that we acknowledge their role in society. I acknowledge the role of shipping in society, both in its good and in its duties as well towards the environment and towards the general population. And that means that putting the human at the center, it's also putting the human at the center of the company. We need to give the tools to the people to make the right decisions. We spoke about performance monitoring. We spoke about giving them a tool on board. We ask a lot from our sailors, and we ask a lot from people sitting ashore in the different shipping companies. We need to give them the tool so that they can do the work that they're asked to do with all the different challenges that they have to tackle. And that means more people around the table, both management, technical people, operational people, charterers, talking together, trying to problem solve instead of, bickering and trying to find whose blame it is or whose responsibility it is. So that's my wish list, really.
Because at the end of the day, as you said, we are all in the same boat. So yeah, at the end of the day, to speak in nautical terms, put in that sense. Martin, your thoughts?
Well, my thoughts are that the ship operator takes more care about his instrumentation, about his fleet, about the engine rooms. And we have seen in the past that many ships, they run with even outdated instrumentation, outdated sensors which not work anymore in the range which they should. So they should take more care in new installations which are not a big investment, I have to say, which have a very short return on investment if it comes to fuel meters, if it comes to viscosity measurements, steam valves. So my advice is really, and with that's what I'm saying, with the next 20, 30 years still with the HFO related vessels and driven vessels, take more care on the engine room, take more care on the operation of your engine, and take more care on the maintenance of the whole fuel systems. Okay, and Jean-Philippe, your wish list for the future, for the near future?
Yeah, I sort of agree with what Tom said. I think being proactive and with respect to new technology would help a lot. You know, these technologies are pretty new, but I think if the industry is proactive in that domain and let us show them the capabilities of what these new kind of system can do, then I think it will all be beneficial for everyone.
Okay, thank you all very much. Thanks. I would like to thank you for taking the time to join us. The same applies for our viewers. Thank you all very much, and trust to see you in the next session in the near future events. Thank you very much.
Thank you very much. Safe links to all.